Good morning, dear children. Welcome to the sixth module of chapter Force and Laws of Motion. In this module, we are going to study about Newton's third law of motion. The first two laws of motion tell us how an applied force changes the motion and provide us with a method of determining the force. The third law of motion states that when an object exerts a force on another object, the second object instantaneously exerts a force back on the first. And this action and reaction acts on two different bodies. When two players of different team collides with each other, both of them feel hurt because each applies a force on other person. Consider a ball at rest on a table. The object that is the ball exert a force on the table and the table exert a force on the ball. There are two forces coming into play here. This is the result of the interaction of the ball and the table. They are equal in magnitude and opposite in direction. So they are called action and reaction forces. The force exerted by the ball on the table is action force and the force exerted by the table on the ball is reaction force. So by this we can conclude that to every action there is an equal and opposite reaction. And this is Newton's third law of motion. According to this law, when two objects interact, force on each object is equal in magnitude but opposite in direction. Now let us understand Newton's third law of motion with the help of an activity. For doing this activity, the materials required are two spring balances, one having 5 Newton, the other 10 Newton, and an iron rod. Take spring balance of 5 Newton and attach one end of the spring balance to an iron stand and take spring balance of 10 Newton, then attach to the hook of the first spring balance. Hold it horizontal to the table to view the reading on both balance. Apply force on the second balance. Note down the reading on both the spring balances. Force exerted by the second spring balance on the first F21 is equal to action. Force exerted by the first spring balance on the second, force 12 F12 is reaction. So we can conclude that action is equal to minus reaction. Minus sign indicates opposite. Now let us see applications of Newton's third law of motion. While we are walking on the road, we push the road backward. The road exerts an equal and opposite force on our feet to move forward. While we are rowing the boat, we apply force on water in the backward direction. Water apply force on boat in the forward direction. What about when bullet is fired from a gun? It exerts a force in the forward direction on the bullet and the bullet exerts a backward force on the gun. This results in the recoiling of gun. This is a perfect example of Newton's third law. But if the force exerted by the gun on the bullet is same as the force exerted by a bullet on the gun, then why doesn't the gun accelerate with same acceleration of the bullet? Here, same magnitude of forces but different acceleration. And why does this happen? This can be explained using Newton's second law of motion. Newton's second law of motion says that force is the product of mass and acceleration. So we can write F is equal to m into A. So we can write A acceleration is equal to F by m. So as mass increases, acceleration decreases. So here mass of gun is more than the bullet. So acceleration of the bullet is much more than the gun. Now third law of motion can be illustrated when a sailor jumps out of a rowing boat. As the sailor jumps forward, the force on the boat moves it backward. Also, when you consider a big boat having greater mass, acceleration produced will be less. So, as the mass increases, acceleration will be less. Now, do an activity. Place a retard stand on the table, take a test tube, pour some water into it, and now put a cork on the mouth of the test tube. After that, you have to suspend the test tube horizontally by two strings or wires. Now, with the help of a Bunsen burner, we can heat the test tube until the water gets vaporized and the cork blows out. Here we can see the direction of movement of the test tube as well as the cork cap is opposite to each other. It is because the water converts the steam which exert a force on the cork and causes to blow out. And also we can see that test tube recoils in the direction opposite to the direction of the cork. By this we prove that to every action there is equal and opposite reaction. Thank you.